Welcome to Khetztutorials, and in this video I'll be talking about factorization of cubic polynomials. So let me just write that down quickly. So factorization of cubic polynomials. Okay, so basically cubic polynomials have the highest power as 3. So if you look at your expression or your equation, you basically expect to have the largest power as 3. That is what is meant basically by cubic. And there are quite a few ways that you can use to factorize. In a previous video, which I'll link to this video, I talked about the factor theorem and stuff like that. And in that video, I specifically used long division to find the other factors when given a certain factor. Now, what if you have an expression and you don't even know? So let's do this. So there are two ways to do this. So I'm going to talk about inspection, something called inspection, according to some textbooks. And the second method which I'm going to use is synthetic division. Right? Okay. So let's say you're given some sort of equation, or let's just write it as it is, x cubed and some other things with a constant or whatever the case may be. Now in this case, we don't have a factor to start with, so you literally have to find all of the factors. The maximum power is 3. So the factors, you expect to have 3 factors of this form, of a linear form, having x, x, and x, and when you multiply, the maximum power should be that. So basically, we want to find all of these 3 factors given a certain equation, which is a cubic polynomial, basically. So how do you start? So let's talk about the first method, which is inspection. So let me just open a new page. And so this is the first method, inspection. And this will be an example-based explanation because I'm just going to go through an example to actually show you how to do each of these methods. So let's say this is what we have in front of us, or let's say this is what we're supposed to find the factors for, or this is what we're basically supposed to solve because it's an equation. So you have to now find each of the factors, equate them to 0, and then extract the values, the exact values from that. So this is our exercise, and the question is, how would you approach such a thing? Well, with quadratic equations, it's quite simple, right? You basically just factorize using any method which you're comfortable with, and it's straightforward. You can basically just look at the form of this, the form of that, multiply this, whichever method that you usually use for quadratic equations. But with this, it's not exactly apparent what you're supposed to do. But one of the easiest ways that you can actually do is to find one factor, which is a linear factor. And a linear factor basically has a maximum power of 1. So you're going to find something in this form. Then the next factor will be a quadratic factor. And this quadratic factor you can then break down using what you already know, which is the factorization of quadratic expressions or equations. And just take this down. So now I have a linear factor, and a linear factor. And multiplying the 3 will give you this cubic function which you have in front of us, right? So let's first do that. Let's first find a linear factor. So we want to find something which is basically a factor of this, but a linear factor basically. So how do you do that? So what you do, so this is the first step. You look at your constant in the equation and you try the factors of this constant. So if we were to talk about the factors of this 8, you basically have, and including, don't forget to include your negative numbers as well. So if we were to talk about the factors of this thing, you basically have stuff like that and a bunch of other things I've left out, -2 and that, for example. And yeah, so basically you consider all of the factors of this -8. It's actually -8. So out of all these factors, you're basically going to use the factor theorem, which says that if you put a value, we can call it b or whatever, and it gives you a remainder of 0. And once again, I'll link the video to the factor theorem to this if you haven't watched that. So now if we have a value which gives us a remainder of 0, we basically know that this value b, right, of this form is a factor. So that is what we're going to do right now. So if we substitute one of these factors of -8 into this expression and it gives us 0, we basically know that that factor is one of the factors of the cubic polynomial, right? So that is what we're basically going to do. You have to try a bunch of factors. So for example, we can try f of 2. So let's try that and see what we're actually going to get in this case. So once again, we're looking at the factors of -8, and whichever factor gives you 0, you can take that to be one of your linear factors, right? So that is the first step. The first step is to find a linear factor. And then the second step will be to find the quadratic factor, and then finally factorize. So let's write that down actually. So let's write it down. So 1, find the linear factor. 2, find the quadratic factor. And then 3, factorize the quadratic factor. And finally, you basically have your answer, right? So let's follow these steps and see where we get to. So let's say we were to take 2 as a factor. So we're trying out a bunch of values. We aren't sure which one will give us 0, right? So this will give you 8. This should give you 20. This should give you 4, and that is that. And if you look at this thing over here, this is much, much bigger than that. And just subtracting this and that should leave you with just this portion, which is 24, which is not equal to 0. So our aim is to find a factor of -8, which will actually give us an answer of 0 if we substitute it into this equation. So let's try another factor. Let's try something like 1. So if you try 1, this is where we are going with this. So let's see what 1 gives us. So we have 1 over there, we have 5 over there, 2, and minus that. On this side, we basically have 8 and -8, which is equal to 0, which means that x minus 1 is a factor of this cubic polynomial. So once again, I'm saying this quite a lot of times, you look at your constant, then list, you can either list or just take them out of your head if you like. So just try the factors of whatever constant that you have. Try them in the equation, basically substitute them wherever you see x. And then if that factor gives you 0, like in this case for 1, you basically are going to write it in this form. So it is now a factor of the cubic polynomial. And now you basically want to find the appropriate quadratic equation or quadratic factor, which you can multiply it by to find the original cubic polynomial, basically. So in the previous video, I basically used long division, but now we aren't really focusing on that. I'm talking about a method called inspection right now. So let's do it a bit differently. So using inspection, here's how you basically do it. So the original cubic polynomial basically has x cubed. Now that x cubed basically comes from multiplying this x with that ax squared. And these are coefficients, by the way. So we want to find the exact values of these coefficients. The easiest one to find will be the constant, because this constant only comes from you multiplying this constant with that constant. There isn't any other multiplication that will lead to the final constant in your original equation. So you already know, or you already can find what the constant in the quadratic formula should be. So we can also write this as just this for now. So we already know what c is. It just has to be plus 8, right? Because if you multiply this plus 8 with that minus 1, as you expand all of this, you should get that minus 8, which is in the original formula. So we're basically breaking down the original formula. That is what factorization is all about. And now we want to find the appropriate coefficients which will give us the original polynomial. So the x cubed in the original has a coefficient of 1, and that x cubed only comes from you multiplying x with ax squared. That will give you ax cubed, right? Now, since we now have ax cubed and the original has a coefficient of 1, you can just basically look at this and conclude that a just has to be 1, because the original equation has a coefficient of 1, and the multiplication that will lead to that x cubed is of this form. It's ax cubed, so a just has to be 1, so that is out of the way. And now we can just add that into our equation. So we basically have this. This is what we have right now. And the last thing that we have to find is b. So how would you find b? So here's a method to find b. So b basically is a coefficient of x, but we have to look at what it actually affects, right? So if you look at the coefficient, for example, if you look at the coefficient of x squared over there, the contribution of this bx actually affects that 5x squared, because as you expand this thing, you should actually multiply the x, which is from that point, with this bx to get your something squared, right? But that is not the only thing that actually affects or that actually contributes to this original 5x squared. Another thing is actually this x squared, and that will be multiplied by that constant over there, right? So you basically have bx multiplied by the x contributing to the x squared factor, and you have a constant multiplied by the x squared also contributing to that x squared factor. So this is the final value that we're aiming for in the original equation, and it's made up of x multiplied by bx as well as minus 1, which is the constant, multiplied by x squared. So these are the two things, or these are the two things that basically make up this factor in the original equation. So now that we have bx squared minus x squared equals to 5x squared, we can now equate this stuff and actually see where it will actually lead us, right? So we have something like, let's look at what we have. So we have b minus 1 x squared equals to 5x squared. So you can equate b minus 1 to the 5, because these will just cancel out if you wanted to do it like that. And your b should be 5 plus 1 equals to 6. So we now have the quadratic factor as well, and we have x minus 1 x squared plus 6x plus 8 equals to 0. And we now have our linear factor as well as our quadratic factor, but we aren't quite done. We now have to factorize this so that we finally have our 3 factors. So these 2 brackets are from factorizing this quadratic factor. And let's do that. So if you factorize that, you basically should expect to get x plus 2 and x plus 4, depending on whatever method that you use. Basically should get this. And your answers would then be x equals to 1 and x equals minus 2 or x equals minus 4. So that is how you basically factorize using inspection. So you basically look at your original equation and then take the factors of this that will give you this 0 after substituting. And then that will be one of your factors, or that will be your linear factor over there. Once you have that linear factor, you can then multiply, or you can then expect a multiplication with a quadratic factor, so that this multiplication would ultimately lead you to that power which you're looking for. And you can then look at your constant over here to determine the constant of your quadratic factor, because you'll get that from multiplying this constant with that constant. that is what we basically did to find this plus 8. If you multiply that minus 1 with this plus 8, you should get the minus 8 in the original equation. That is the first thing that you can do. And now secondly, you should look at your coefficient of x squared and see what would actually contribute to that coefficient, and that would be x multiplied by bx, plus c, which would be the constant in the linear factor, multiplied by this x squared over here. That would also contribute to your x squared, which is in the original. So you basically equate your original x squared to this contribution, which is x multiplied by bx added to the constant multiplied by ax squared, which is what we did already. And then you'd now find your b, and you now have all your factors. After getting your factors, now you then factorize and then find your answers. So that was inspection. And now we can move on to the other method, which is called synthetic division. So let's talk about synthetic division. So this follows a similar approach, but it differs when you then find your coefficients. So here's how it differs. So we'd first find the linear factor as well. Then you'd find your quadratic factor as well. So I can say the steps are quite the same, but the way that you actually find this quadratic factor is actually different. Then you'd factorize whatever has to be factorized, and then finally you'd find your answer, right? So once again, let's follow these steps given the same example or the same problem, which is this one. We found out in the previous example, in the previous iteration of this particular example, that we actually found this to be a factor. So we don't have to do that again. What you have to remember is that we just substituted, or we tried the factors of minus 8, and whichever factor led to 0, so after substituting the factor, whichever factor leads to 0, you can basically take that as one of your factors. And now that we have that factor, we basically want to find the quadratic factor, which we can multiply it by to get this original expression, right? So this is our task now. And to do that, here's how this differs, right? So you basically are now in this synthetic division method, you're going to take the coefficients from the original equation or the original expression. So the coefficient of x, so make sure, first of all, make sure that your values are written. So this is important, right? Values, this is a v, by the way. Right, values in descending order of powers of x, or basically in descending powers of x, and this is what I mean by that. So the highest power of x first, which would be this one, then the next one, then the next one, until you get to the constant. So start with the biggest power of x and then have them descending like that. So once you have that in that form, which is descending powers of x, you now take the coefficient of each of the powers of x, starting with x cubed. So the coefficient of x cubed, as you can see, is 1. The coefficient of x squared is 5. The coefficient of x is 2. And then you're going to take your constant. So this is what we have in front of us. And what you're going to do now, so what I'm showing you now is how you'd find this quadratic factor using synthetic division, right? So now you basically draw some sort of line thing, or an L, if you want to call it that. And after that L, you basically should have your factor, which you already found. So the factor that we already found is 1, right? So that is the factor that we've already found, it's 1. And here's how you'd go about this. You take the coefficient of x cubed, you take it down, you just write it as it is. Then you're going to take your factor, which you already found, and you're going to multiply it by whatever you have down there, and that is 1 multiplied by 1, which would just be 1. You take that 1, then add it to your value, whatever coefficient that you have down here, right? So that'll be 6. And this this is us basically finding each of the coefficients of the quadratic factor. So this, in the general form, will be something like this, a quadratic factor. So this will be A, and this will be B, and the next thing will be C, and the last one, we expect the last thing to be 0, which is a remainder, right? So let's work through it and see if we actually do get that. So now we're going to do the same thing. Take whatever factor that you have, in our case it's 1, multiply it by whatever you have down here, which is 6, and that will give you 6, and then you take that 6, put it up here, add it to the 2 over there, and now you have your 8, which means that will be the value of your C. So we now have x squared plus 6x plus 8. And then finally, you take this, multiply it by that, give you 8, take it up here, add it to minus 8, it should give you 0, which is your remainder. So I'd say this is a much quicker method compared to the one which you just did previously, but we did get the exact same answer. Now that we have this exact same answer, you're just going to multiply it by that same factor as well, which is x minus 1, and equate that to 0. And doing the same thing, basically we're now at the factorization stage. You should get the same answer as well because it's the exact same thing. And you now have all your factors, and once again you can just write all of your answers, and we are done. So that is how you can factorize cubic polynomials using inspection or synthetic division. So just go through the video again and check which one you're comfortable with, or if you have any other method, or if you'd prefer to use long division, you can check my previous video. And that is all from me in this video. I will see you in the next video.